Yeah, so this next round graph's a little bit different than the last ones. For these, you're only going to need 2 points, and one's going to be the vertex and then a second point. And for all the problems I picked, the vertex is going to happen at x equals 0. To kind of simplify matters, as we learn a little bit more about parabolas, we can move that around. But for these ones, let x equal 0. So here, if I let x equal 0, and then make sure that you are on the parabola tool, so you're graphing that if you're not on one of these ones. So if x is 0, y is 0, so that's going to be my vertex. And then I would put in a number like, so that 1/4, I'm going to want it divisible, that what's going to be on the x squared, I'm going to want it to come out to something divisible by 4. So like the two choices that seem good to me, like one doesn't seem good because I'd have 1/4 and that'd be hard to graph. If I put in x equals 2, then 2 squared would be 4, and 1/4 of 4 would be 1. So that seems like a pretty easy point. And then the other one I was thinking was if I put in x equals 4, just because I know 4 will go into it, I would have got 1/4 of 16, which would have been 4, and that would give me that point right there. So that is what that is asking for part A. And then for part B, it's asking when does this equal 4? So if you look here, when when y is 4, when the output is 4, x is 4 or x is -4. And then that works for any of these problems that involve the graphing. Again, something like this one. This looks tricky maybe, but it's not. If x is 0, y would be 6. And then just if x was 1, 1 squared would be 1, 6 minus 3 would be 3. And there's your graph. And then it's just asking where does this equal 3? It looks like, -1 and 1. So that's the idea of those ones.